So our first strategy that we talked about for solving quadratic equations was to graph our function. So that's what we did. We had a parabola, we graphed it, we knew it needed to be equal to some number, so we graphed that number and we looked for those intersections. Graphing is a perfectly fine strategy if I have a parabola that I can graph easily and nicely. If I have a really crazy lead coefficient, like if I had, instead of just -1, if I had negative 0.275, that would make this harder to graph. If I had negative 15 as my lead coefficient, that would make this harder to graph. So my parabola is relatively easy to graph. This isn't too bad. And then if my value I want to be equal to happens to intersect my graph where I'm going to have intersection points at corners, that's not too bad either. If, let's say I wanted to be equal to, let's say -2, and I were looking for these intersection points, that would be harder. It would be harder to find those solutions, right? Because they're not at corners. I'm going to have to do some estimating here. I'm not going to be able to find those exact solutions. So graphing is an option. It's not always going to be our best option. And in several cases, it's not going to be our most efficient option. So there are problems that we're going to look at that we can probably solve faster using a different method rather than graphing. Okay. So if you would for me, please turn to page 5 if you're not already there. Today we're going to look at another option, okay, another strategy that we use. So for our first function that we're looking at here, x squared equals 4, this is something that we could definitely solve by graphing. Our quadratic here is just our parent graph, so I can graph that. That's not too bad. I've got our vertex at 0, 0, up 1, out 1, and then up 1, 2, 3, 4, out 2. There we go. There's my parabola. And then I want to know, when is this equal to 4? So 1, 2, 3, 4. And I've got intersection points here and here. My solutions then would be -2 and +2, right? The x values for those intersection points. This is absolutely something that we can and just did solve by graphing. But even on a simple problem, graphing may not be our fastest, our most efficient option. So I want to take a look at the same problem, but solving it using a different strategy. So here I have x squared equals 4. I want to get x by itself. That means I want the square to be gone from here. I can undo a square with a square root, right? Square and square root are kind of opposite operations, like addition and subtraction or multiplication and division. So if I'd like to solve this, I could use square roots here. The square and the square root will undo each other. And I'm left with x equals, do we know the square root of 4? 2. Not too bad? Pretty quick? Right. There's one issue with the work that I've just done. We know from our graph that we're supposed to have 2 solutions here, and I've only given 1. Yeah, here's why. Okay, here's why I'm only seeing 1, because I've forgotten something very important about square roots. When I take a square root, I want to know what number multiplied by itself gave me 4 in this case. So 2 times 2 does give me 4, but -2 times -2 also gives me 4, right? Since negative times a negative gives us a positive. So let's say I were going to solve x squared equals 9. I could take a square root and get x by itself. The square root of 9 I know is 3, because 3 times 3 gives me 9. But -3 times -3 also gives me 9. So as we're working today taking square roots, I have to remember that it could have been the positive number that I've got there. It also could have been its negative. 3 times 3 gives me 9, but so does negative 3 times negative 3. So the adjustment I need to make here is I've already recognized that positive 2 times positive 2 would give me 4, but so would negative 2. So we're going to include this little sign as we're working today. This is what we call plus or minus sign. So there are my two solutions. X could be positive 2 or negative 2. Questions for me so far? Okay. So let's take a look at another example. Top down to the bottom. X squared plus 8 equals 28. Let's forget for just a second that that's an x squared. Let's say it's just x plus 8. What would you do here to solve for x? Yeah, so we're going to do the same thing. I don't want to take a square root until I have the squared thing by itself. The squared thing needs to be by itself before we take a square root. So I'm going to move that 8 to the other side. And now that I have x squared on a side by itself, we can take a square root. So square root, square root. And I get x equals, since we're taking a square root, I know I've got the positive and the negative version that I need to consider. And does anybody know the square root of 20? Yeah, me either. 4 squared would be 16. That's too small. 5 squared is 25. That's too big. So it's some number in between 4 and 5. I do not want you to type this into your calculator and give me a decimal. Okay. Did anybody put a decimal into that Khan Academy assignment the other day? And it marked it wrong, right? Because what it wants and what I want from you are exact answers. So if you're giving me a decimal, you're giving me an approximation, okay? Especially when you have to round that decimal. So the reason I assigned not just the practice set, but also the video to you, so you had a refresher on how to simplify square roots if you forgot. So we're going to take a look at that here. So 620 does not have a nice square root. What we've got to do is factor this. We're going to do a little factor tree with 20. If you think of 20 as 4 times 5, great, right? 4 and 5. If you think of 20 as 2 times 10, great, right? 2 and 10. It doesn't matter where you start because we're going to factor down the prime numbers. So if you did 4 and 5 instead, then that 4, you can factor into 2 and 2. I did 2 and 10. 2 is prime, but 10 I can factor into 2 times 5. So that's what I'm going to do there. And now remember, the idea behind a square root is I want a number times itself. So as I'm looking at simplifying something that actually doesn't have a nice square root, I'm going to look for numbers times themselves. I'm going to look for pairs. In my prime factors here, I've got a pair of 2s. That means that I can actually simplify this and pull a 2 out. Anytime I find a pair, I can pull one of that number out. So I've got a pair of 2s. That means I get to pull a 2 out of the root. Now, 5, the other number left in my prime factorization here, 5 doesn't have a partner. It doesn't have a pair, so it's going to stay under the root. So my solutions here would be plus or minus 2 root 5. Questions for me on A? Okay, let's keep going. Let's take a look at C. Remember, I want to get the squared thing by itself. I, again, basically could treat this just like that square's not there. If that square wasn't there, what would you tell me to do as my first step? So that's what I'm going to do. Subtract 10. So I get 2x squared equals 200. I want to continue getting x squared by itself. So I'm going to divide both sides by 2. And I get x squared to be 100. Now that I have this squared term by itself, I can take a square root. So x equals, since I'm taking a square root, plus or minus, and do we know the square root of 100? 10. Let's take a look at E. Same idea, same strategy as C. So I'm going to start by moving this 4 to the other side. So I have 8x squared equals 536. Now divide both sides by 8. And I get x squared equals 67. And now we're going to take a square root. So I get x equals plus or minus. If I try to factor 67, I know it doesn't have a nice square root. If I try to factor 67, I'm going to end up with 1 times 67 because this is a prime number. So I'm not going to be able to reduce that root. That means I'm just going to have to leave this as plus or minus the square root of 67. Questions for me so far? Okay. I hop over to B. What's my first step here? Divide by -6. So I get x squared equals 69. Then what do I want to do next? Take the square root. So I get x equals plus or minus. This one we actually can factor. I could factor this as 3 times 23. And then 3 is prime and 23 is prime. So I can't factor either of these anymore. I don't have any matches here. I don't have any pairs. So I can't pull anything out. I'm just going to leave this one also as the square root of 69. For D, same idea. I want to get the squared thing by itself. I'm going to start by moving that 10 to the other side. So I get 9x squared equals 81. Then I'm going to divide both sides by 9 because I want x squared by itself. So I get x squared equals 9. And then I'm going to take a square root. Do we know the square root of 9? 3. So x equals plus or minus 3. And then our last one on page 5, F. Be careful with your signs on F. I want to move the 3 to the other side, so I need to subtract it. And then this negative sticks with the 4x squared. So minus negative 4x squared equals negative 88. Divide both sides by -4. And we get x squared equals 22. I want to get rid of the square, so we're going to take a square root. And we get x equals plus or minus 22 would be 2 times 11. 11's prime. There are no pairs there, so we're just going to leave that as the square root of 22. Questions for me so far? Not too terrible? Okay. Yes, you do need to include the plus or minus. Remember when we didn't include the plus or minus on that first example, we missed one of our solutions. Okay, so I need to make sure that I'm including all of my solutions. Okay, so we're going to look at some more practice problems on the next page. At the top of page 6, I want you to notice the format, the setup here is a little bit different. I don't have x squared. I have x in parentheses with something squared, okay? I actually don't care what I'm squaring. I don't care. We saw x squared for all those problems we just did. If I had like r squared or something, if I switched up the variable on you, or if I had something in parentheses being squared, I don't care what I'm squaring. I just care about getting the squared thing by itself and then taking a square root. So I'm actually just going to cover up that stuff in parentheses. All I care about is getting the squared thing by itself. So is there anything on the same side as the squared thing right now? Is there anything I need to move? Nope. So since the squared thing's by itself, I get to take a square root. Just like before, the square and the square root undo each other, and I'm left with x plus 1. And then equals on the other side, plus or minus, and we know the square root of 16, 4. Now, if you didn't remember that off the top of your head, or if there was some other number you were looking at and you're like, I don't know the square root for this number, you can still go to that factor strategy. So if you went to go reduce this root, you said 16. Well, gee, that's 4 times 4. Well, there you just answered your own question of what is the square root of 16. But if you didn't think of it as 4 times 4 and you thought of it as 2 times 8, that's okay. You can break up 8 into 2 times 4, and then you can break up 4 into 2 times 2. So there's a pair of 2s. That means you get a 2 outside. There's another pair of 2s. That means you get another 2 outside. Anything you take outside of the root, you multiply together. And so 2 times 2 gives you 4. You still got the same number, right? You still got the same simplified version of that root. You just took a different avenue to get it. Okay, so x plus 1 equals plus or minus 4. Now, for all the problems that we saw on page 5, if I flip back for just a second, I had positive 2 and negative 2, or positive 3 and negative 3, or positive 10 and negative 10, or positive square root of 69 and negative square root of 69. I had the same sort of absolute value number, but one positive and one negative, right? And we saw this with some of our graphing problems. If I flip back here, I had, it would have been in our practice the other day. Here we go. Positive 1 and negative 1, right? But every problem we looked at when we solved by graphing was not positive 1 and negative 1. Here we had a 5 and a 9. Here we had a negative 5 and a negative 2. Here we had a 1 and a 2. Here we had a negative 4 and a 0. So I know that solutions to quadratic equations don't have to be the same number, positive and negative. That's not a rule, right? That's what we've seen so far for our problems for today, but that doesn't mean every problem has to be like that. So if we take a look at example A here, I know that x plus 1 could give me positive 4, or it could give me negative 4. My x would have to be different values to get me such different numbers. So what we're going to have to do for a problem like this is actually split this up and say, well, if x plus 1 gives me positive 4, what would x have to be? And if x plus 1 gives me negative 4, what would x have to be? So once I split these up, I'm going to solve for x the same way you would have solved one of these last semester or last year, or just like we solved a minute ago. I'm going to get x by itself. So I get x to be 3. And then over here, if I get x by itself, I get x to be negative 5. I still have 2 solutions, just like positive 2 and negative 2 were 2 solutions to that very first problem. Just this time, they're completely unique numbers. Questions for me on A? Okay. Let's hop down to C. C is just like the problems that we worked on the last page. I just have an x that I'm squaring here. The only difference is I've got a little bit more to unravel. Okay? So let's start by moving this 5 to the other side. So I get 3 times x squared minus 14 in parentheses equals 11 minus 5 gives me 6. And now I'm going to move this 3 once I move this 3, I don't have a reason to put the x squared minus 14 in parentheses anymore. So I'm not going to. So x squared minus 14 equals 2. And now I can add 14 to both sides. I get x squared equals 16. Take a square root. Now that I have the squared thing by itself, I can take a square root. And I get x equals plus or minus 4. Questions for me on C? The last type of problem that we're going to look at is E. So notice I have 2 x squared terms and they're split up. They're on different sides of the equal sign. So again, I want you to pretend for me that this is not an x squared problem. There we go. Let's say it was just a plain old x problem. You guys have solved stuff like this before. What would you do if you were solving for x here and you had x's on different sides of the equal sign? What would you do? Yeah, move them together, right? I don't want them split up. I would move them together. So that's what I'm going to do here. This any different way because I have x squared. I treat it exactly the same way. And so you said I would move the 4x squared to the other side. That's what I would do too. I like when the variable has a positive coefficient. That's my personal preference. If you always like, I know some people always like their x's to be on the right. Cool. Move your x's to the right. That's fine. I like for the coefficient to be positive, so I'm going to move them so that the coefficient is positive. So I'm going to add 4x squared. So this would give me negative 10 equals x squared plus 4x squared would be 5x squared minus 330. Now what do we want to do? I want to get the x squared by itself. Yeah, I would move the 330 over. So this would give me 320 equals 5x squared. Now we're going to divide both sides by 5. So that would give us 664. And then finally, I want to get x. Right now I have x squared, so I'm going to take a square root. Square root of 64 plus or minus 8. I would like you guys now to try B, D, and F. Try B, D, and F. We'll talk about them and check our work in a couple of minutes, but I want you to try B, D, and F. Yeah, if you use for root, then you're gonna another minute or so and we'll take a look at these. B is pretty similar to E, that last example that we did together. I've got two different x squared terms. I want to move them together. I'm going to start by adding 2x squared to both sides so that my x squared terms are together on the same side. X squared plus 2x squared would give me 3x squared. Then I've got minus 12 equals 15. Now I'm going to move the 12 over because my goal is to get the x squared term by itself. So plus 12, that gives me 3x squared equals 27. Now I'm going to divide both sides by 3 to get the x squared term by itself. And I get x squared equals 9. My last step here to get x by itself is to get rid of that square. So I'm going to take a square root on both sides. And I get x equals plus or minus. Do we know the square root of 9? 3. Yeah. Plus or minus 3 there. Questions on B? Okay. D is similar to example A that we did together. So again, I've got something in parentheses being squared. I don't care what's in parentheses. I just care that this is the squared thing. So I want to get the squared thing by itself. My first step is going to be to move this 36 to the other side. So I've got 4x plus 1 squared equals 36. Now that the squared thing is by itself, I'm going to take a square root. I do not want to move anything inside parentheses right now. I have to get rid of the square before I can touch anything in those parentheses, okay? So don't move the 1, don't divide by 4. We can't touch any of that yet. I have to get rid of the square. I've got to take a square root. Now I've got 4x plus 1 equals plus or minus, we know the square root of 36. 6, I think we saw that one earlier today. And now we're in the same situation that we were in here. I've got something besides x equal to plus or minus a number. Okay, something besides just plain old x equals plus or minus a number. So at this point, I've got to split this up. So 4x plus 1 equals positive 6, and 4x plus 1 equals negative 6. I've got to split this up. And then for each of these now little baby equations, I'm going to solve for x. So move the 1, and I get 4x equals 5. Then divide by 4, and I get x equals 5/4. It's okay to leave your answers as fractions. Sometimes we're going to get fractional answers. Just make sure they're reduced. This one is, so we're good there. Now I'm going to do the same thing on my other equation here. Move the 1. I get 4x equals negative 7. Then divide both sides by 4. And I get x equals negative 7/4. Again, as long as your fraction is reduced, that is a perfectly acceptable format for an answer. Questions on D? Okay. And then F is our last example here. This looks like something that could have been on page 5. Right? I want to get the squared thing by itself. I just need to move this 8 over. So I get x squared equals negative 28. And I want x by itself, so I'm going to take a square root on both sides. And I get x equals plus or minus. Do we know the square root of negative 28? No. And there's something a little odd about this problem, something a little different. We're taking the square root of a negative number this time. I want you to remember that when we take the square root, so if I use 64 here, we got plus or minus 8, because 8 times 8 would give us 64. Or negative 8, or I should say and, negative 8 times negative 8 also gives us 64. A positive times a positive gives us a positive number. A negative times a negative also gives us a positive number. The only way I would get a negative number is if I did one positive and one negative multiplied together. That's a problem when I'm talking about square roots, because positive 8 and negative 8 are not the same number. Right? There's a reason I differentiate between them, because they're not the same. If somebody owes me $8, right, that's very different than me owing someone else $8. Okay? Or if I talk about a bank account, if I have $8, okay. If I have negative $8, not okay. Okay? These are different numbers. So I can't say then that the square root of negative 64 is positive 8, because it's not. It's also not negative 8. So here, because of this negative sign, I've kind of run into a problem. Okay? In Algebra 2, we're going to talk about how to tackle this problem and how to simplify taking the square root of a negative number. For Algebra 1, I want you in your head to hear like that record scratch sound. Stop, go, that's weird. And then don't simplify it any more than saying you're taking the square root of that negative number. Okay? So in Algebra 2, we're going to talk more about this, and we'll talk about how to handle this, how to simplify something like this. For Algebra 1, we're going to acknowledge that that is strange, and we're going to keep it as it is, and maybe like give it a side eye. Okay? You're not going to see a lot of problems like this in this unit in Algebra 1, but I wanted you to see it here so we could talk about how it's weird, so that next year when you see it in Algebra 2, you remember how we talked about how that was weird, and there's a reason that we need a special sort of strategy to deal with. Okay? So don't pack up just yet. I'm going to talk about what we're going to see tomorrow. Okay? So if I take a look at A for just a second, if I move this 16 to the other side, this looks like vertex form, right? Yeah, we did a ton of graphing over the last few days, so we should be really familiar with vertex form. So this looks like vertex form, and then I wanted to get the square thing by itself, so I moved the 16, and then we did the square root, blah, blah, blah. We know how to solve the rest of that. But I want to point out that, again, That's vertex form. What we're going to look at tomorrow is a continuation and sort of an extension of using square roots to solve quadratic equations. But this time we're going to start with stuff that's in standard form. We're going to rewrite it as vertex form so that we can then use a square root to solve it. Okay, so that's where we're going to go tomorrow. There's no new homework for tonight. Instead, if you have not yet done your Khan Academy assignment, I want you to work on that tonight because we're going to see more square roots and more simplifying tomorrow. Okay.